This presentation is an explanation of action potentials, which explains how nerve impulses are passed through our body. So first of all, electrical potential is caused by a difference in charges from one point to another. So here's an example where they're using batteries, but we'll be looking at the difference in charge concentration inside a nerve cell versus the outside of a nerve cell. Oops, we have a typo there. Okay, so the inside of a nerve cell is going to be more negative, and the outside is more positive. Okay, so resting membrane potential. This is when we have more negative charges on the inside of the cell than the outside. And we're going to walk through what happens when there is a nerve impulse, because we are going to have a reverse in the charges, and that is what allows the nerve synapse to occur. Okay, so the reason why the inside of the cell is negative, first of all, we have anions inside of the cell, and second, potassium is able to move through the cell easier, so we have more potassium that leaves the cell. But typically there's more potassium on the inside of the cell and more sodium on the outside. Okay, so as I mentioned, we do have negative ions inside the cell, such as sulfate and phosphate. They cannot enter or exit the cell, so they're just going to stay inside the cell. There's some examples. Okay, so at resting potential, so when we have a negative, about negative 70 inside the cell versus the outside, we have sodium leaking in very, very slowly, okay, which would be causing it to become more positive, but potassium is moving less slowly, okay, so potassium is also positively charged, so that would make it more negative inside the cell, but I'll show you guys with a really, really, really simple drawing here on the next slide. Okay. Now, to work to compensate, we have a sodium-potassium pump that is going to work against the sodium and the potassium channel. So the sodium channel allows sodium to move into the cell, and potassium channels allow potassium to move out of the nerve cell. But the sodium-potassium pump is going to be pumping 3 sodium ions out and 2 potassium ions back into the cell. Okay, so if you look just even relative to the sodium and potassium, if you have 3 positive charges moving out and 2 positive charges moving in, the inside would be more negative than the outside. Okay. All right, so I have these negative charges drawn in here for you guys. Okay, those are going to represent those different ions, the ATP, the phosphates, the sulfates, organic acids, etc. So those negative charges are going to stay there because remember they can't move in or out of the cell. And typically inside the cell, we would have more potassium ions. Now I'm going to keep this super simple and only draw a few of each ion. Okay, so by the way, it's considered an ion because it has a positive or negative charge. So this would be a cation that's positive. And then we'll have sodium ions on the outside. Okay. So a stimulus is going to cause sodium channels to open, causing sodium to rush into the cell. So we are going to still have our potassium ions here. And now this channel has opened up So sodium ions are coming into the cell, okay, from the outside. Move it down. Okay, so draw on a few more of those. Okay, so from where we were at on the last slide, okay, so see we have these negative charges inside the cell, and we have 4 positive charges. So now that the sodium channel has opened and sodium is rushing into the cell, now I have more positive charges. Okay, so right now I have 1, 2, 3, 4, 5, 6 positive charges. Okay, on the last slide, I only had 4 positive charges. So what's happening here is the cell is becoming more positive. Okay, so the stimulus causes sodium channels to open, sodium starts rushing into the cell is going to become more positive. Okay, so you see right here, this is called depolarization. So you see that on the graph. We're moving up towards a more positive area of the y-axis. Okay. So the sodium channels close. So now we've got those few extra sodium. Okay. So this is after depolarization has occurred. So we had some of the sodium ions rush into the cell. So obviously it would be a lot more than this. I just want to keep it real simple so you can see that now we have 6 positive charges on the inside of the cell. So now the potassium channels are going to open up. Okay, and this is going to allow potassium to exit the cell, right? And because the potassium channels are slower to open, depolarization is complete at this point, so we've already become more positive, and now slowly the cell is going to start becoming closer to neutral because these potassium ions are going to move out. Okay, and the cell is going to become more negative. So I'm going to go ahead and I'm going to take those out because they would leave through the potassium channel. And now they're going to be out here. Okay. So you can see here from the last slide, back up. So here, remember, we became more positive, so that was depolarization because the sodium channel opened up and the sodium were rushing in. Now we have potassium leaving, and since potassium are positively charged, now overall, based on this image here, I've got overall just 3 positive charges here, so this has become more negative. Okay, so this would be repolarization. Okay, so since the potassium ions are moving out of the cell, they moved out this way, now the cell is going to become more negative. So that would be this portion of the graph. Okay, so with the potassium channels open, the membrane begins to repolarize back to its resting potential. So because we have more of the potassium moving out of here, that's going to be canceling out some of those sodium. I swapped the colors that time. Let me fix that really quick. So we have some of those sodium that had come into the cell from the first step. Okay, we first had that nerve impulse, sodium channels open, they're going to move into the cell. And now we had some of the potassium ions moving out of the cell during repolarization. Okay, so we're moving closer to going back to being overall negatively charged. Okay, so we want to have more positive charges on the outside of the cell than the inside. That would be the resting membrane potential. Okay, so repolarization typically overshoots the resting potential. So what's going to happen is we're going to get too many of the potassium ions on the outside of the cell. We still only have a few of these guys inside. Okay, so basically we're shifting positive charges in and out of the cell. So hyperpolarization, we're going to move past the negative 70 millivolts. So in this case, we have all of the potassium has left, so you can see it on the outside of the cell there. Get our graph going. So this part is our hyperpolarization. Okay, so it gets even more negative than 70. Okay, so we went past the point of resting potential. So what happens here is hyperpolarization prevents the neuron from receiving another stimulus during this time, or at least raises the threshold for any new stimulus. So this is just allowing these nerve impulses to be transmitted without being interrupted by a new stimulus. Okay, and then after hyperpolarization, the sodium-potassium pump is going to bring the membrane back to its resting state of negative 70. Let's see if I can kind of draw this in. So what we're trying to do is get things back to normal. So if we still had some of the sodium ions in here, so let's say we had done the hyperpolarization where we lost all of our potassium ions, they had all went out here. And we still have some of those sodium ions from our depolarization step. So we're going to come back to normal based on this sodium-potassium pump. So this is working against the concentration gradient. And what it's going to do is it's going to take 3 sodium ions. So let's say we're going to take these 3. And it's going to take 2 potassium ions, and it's going to pump them through. So we're going to move these 3 sodium ions back out here, and these 2 potassium ions back in here. Okay, and this is going to take energy in the form of ATP for it to occur because it's moving against the concentration gradient. So move these guys. So now I've pumped 2 potassium ions back into the cell and 3 sodium ions back out of the cell. Okay, because remember to start, we had more sodium outside the cell than potassium. Okay, and then it would continue to pump until we're getting back to our resting membrane potential where we had an overall negative charge on the inside of the cell. So we're going to take these sodium, okay, so it's going to pump a 3-to-2 ratio. I'm going to take these 2 guys, move them out. So if we're moving 3 positive charges out and only 2 back in, overall the inside of the cell is going to become negative again, more negative. So that pumps 2 potassium back in and 3 sodium back out. All right. So then we would be back at resting membrane potential.